So now let's tackle the first part of this worksheet. We're looking at reactions, products and reactants together, and we're just trying to decide if these reactions are oxidations, which we would call O in the square brackets, or reductions, which we can write as an H in the square brackets, or we could write as H2 with whatever metal we choose, platinum or palladium or nickel. So how are we going to look at a reaction and classify it as being either oxidation or reduction? What kind of things are we going to look for? So I'm going to give you some tips of things to look for. If you are looking at an oxidation reaction, one of the things that you might see happening is a carbon-oxygen single bond turning into a carbon-oxygen double bond. That's not a guarantee. It's not guaranteed to happen. But if you do see that conversion, if you see a carbon-oxygen single going to a double, then I guarantee it's an oxidation reaction. So let's look and see if we can find any of those. We have starting with a carbon-oxygen double bond, starting with a double bond, starting with a double bond. Oh, here's one that's starting with a single bond. Does it turn into a double bond? Why, yes, in fact, it does. Anytime we have a carbon-oxygen single bond turning into a double bond, for sure, definitely, that's an oxidation reaction. Now again, just because that did not happen, the single going to a double, just because that didn't happen for the rest of these reactions, that does not mean that they're not oxidations. There is more than one way to define oxidation. So maybe they're just a different type of oxidation. So what's the other way to define oxidation? The other way would be increasing the number of oxygen atoms in the molecule, like starting with 1 and ending with 2. So let's see if we have that in any of these. In our first reaction, we're starting with 1 and ending with 1, so no, that's not what's going on here. Starting with 1 and ending with 1, again, no. Starting with 1, ending with 2. So there's another oxidation. Increasing the number of oxygen atoms in the molecule. So those are the two ways that we're going to find oxidation, and those are the only two ways. Now you have two options here about what you could do. You could say, that's how I find oxidation, and therefore everything else must be reduction, because if it's not oxidation, it's reduction. That would be one option. But let's actually talk about how we would find reduction if we were looking for it. So one option with reduction is the reverse of oxidation. So this would be going from a carbon-oxygen double bond to a carbon-oxygen single bond. And we can see for the first reaction that we're looking at, going from a double bond to a single bond. That is oxidation or reduction. In our next example, going from a double bond to a single bond, that's also a reduction reaction. The other way that we could spot a reduction reaction is looking at an increase in the number of hydrogen atoms. Now this one is actually harder to see than increasing the number of oxygen atoms. It's harder for us to see the increasing number of hydrogen atoms because almost all of our hydrogen atoms are hidden in the line structure. And so in order to see whether or not they're changing, we have to go through and count them all up, and it is a little bit tedious to do that. But the first three things that are on this list are all pretty easy to see. And once you've got those three figured out, you should have no problem kind of basically not needing to rely on this last category to help you classify something as oxidation or reduction.